At Rescue Education, we have the best explanation every time. I'm Dr. B, and I'm going to help you easily and rapidly learn organic chemistry. If you like the video, you'll love my book. Learn more about it at rescueedu.com or hear more about it at the end of the video. The second semester book comes out in fall 2020. Today, we're going to talk about the nomenclature of alkanes and cycloalkanes. We'll also introduce the origin and basic approach of the IUPAC Rules. First, let's talk about the overall approach of the IUPAC Rules and the parent alkane names you need to know. This is the molecule limonene. It's the major fragrance molecule of lemons and limes. The name is descriptive, and it only tells you where the molecule is found, but absolutely nothing about its structure. This traditional and old name is sometimes called a common name. In the early 20th century, an organization called the International Union of Pure and Applied Chemistry, or IUPAC for short, started to formulate rules for systematic nomenclature. The idea was to have a name that told you exactly what the structure was. You could draw the exact structure if you had the correct systematic name. If you had a new molecule, you could also name it unambiguously based on its structure. The IUPAC nomenclature for organic structures is based on the names of the straight-chain alkanes, and you need to know these by heart. Straight chain means all the carbons are in a row. The C1 alkane is called methane, the C2 alkane is ethane, the C3 is propane, and the C4 is butane. The next few are easier to remember because C5 starts with pent, C6 starts with hex, and so on. Learning up to decane, which is C10, is usually enough. We will almost always use line drawings, which show long chains as zigzags. So propane is a zigzag with 3 points, butane has 4 points, and pentane has 5 points. Notice that the molecule triconane, the C30 straight-chain alkane, has over 4 billion isomers. It's amazing that IUPAC nomenclature allows you to quite easily and unambiguously name them all. The next thing you need to know are the names of the alkyl groups that often branch off of the parent alkane chain. We say these are substituents on the parent alkane. The alkyl groups are derived by formal, but not actual, removal of a hydrogen from an alkane. Removing any hydrogen from methane gives you the methyl group, and likewise removing any hydrogen from ethane gives you the ethyl group. There are 2 types of hydrogen on propane. Removing the primary hydrogen gives you the long-chain propyl group. Removing the secondary hydrogen gives the isopropyl group. There are 4 butyl groups we can derive systematically. 2 come from butane, and 2 come from its isomer isobutane. Removing a primary hydrogen from butane gives a long-chain butyl group. Removing the secondary hydrogen gives the sec-butyl group, which is also abbreviated S-butyl. Removing a primary hydrogen from isobutane gives the isobutyl group, and removing the tertiary hydrogen gives you the tert-butyl group, which can also be abbreviated as T-butyl. All of these groups have further abbreviations you can use when drawing structures. For instance, methyl is abbreviated as Me, and the tert-butyl group is abbreviated as TBU, but only when drawing structures, never in naming them. Now we're ready to learn the actual IUPAC rules of alkane nomenclature. The first thing you need to do is identify and name the parent chain, which is the longest chain. It's often horizontal, but not always. Then you need to circle and identify each substituent. If you have more than one of a kind, use the prefixes di, tri, tetra, and so on. Next, you have to correctly locate the alkyl substituents. If you have 1, the number from each direction and give it the lowest possible number. With two or more substituents, number in both directions and choose the scheme with the lowest number at the first point of difference. Numbers are separated by commas and are separated from the name by hyphens. In our example, the longest chain snakes through the molecule and is 9 carbons long. So the parent is nonane. The parent name is always last. We have 2 methyl substituents, so this is a dimethyl nonane. Notice it's all one word. Finally, we number in the other direction. We can have either a 3-6 versus a 4-7 numbering scheme. The first scheme wins because 3 beats 4 at the very first number. So this is a 3,6 dimethyl nonane. Here are some sample problems. Pause and try to name these molecules using the systematic IUPAC rules. The first example is very easy. The parent is a propane with a methyl at the 2 position. So this is a 2-methyl propane. You can also call it simply methyl propane. If you move the methyl to the 3 position, it becomes butane, so there is no ambiguous other methyl propane. But this molecule is actually called by its common name, which is isobutane. This is a historical name and is incorporated into the IUPAC nomenclature. In fact, this molecule is known almost exclusively by its common name, isobutane. The second molecule has 7 carbons and is a heptane. It also has 2 methyls, so this is a dimethylheptane. You should easily be able to see that this is a 3,3 and not a 5,5 dimethyl, because you want to give the methyl groups the lowest possible number. The last molecule is also a heptane. In this case, we have 3 methyls, so this is a trimethylheptane. Let's number in the other direction so we can see the 2 competing numbering schemes. From left to right, we can have 2, 5, 6. And from right to left, we can have 2, 3, 6. The first number is the same, so we have to go to the second number to compare. 3 beats 5 at the second number, so the correct numbering scheme is 2, 3, 6. So this is a 2, 3, 6 trimethylheptane. There are a few more rules you need to know. When you have different substituents, you need to put them in alphabetical order in the name. The prefixes iso, neo, and cyclo are included in the alphabetical order. The prefixes di, tri, tetra, tert, and sec are not included. So ethyl comes before methyl because E beats M. The B of sec-butyl beats the M of methyl. Cyclopropyl comes before propyl. Sometimes you can have several competing parents of the same length. In that case, the rule is to choose the parent which gives you the most branches. The more branches you have, the simpler the branches will probably be to name. Finally, there are 3 important common names that are allowed by IUPAC and used almost exclusively: isobutane, neopentane, and isopentane. Here are some sample problems. Name these molecules using the systematic IUPAC rules. The second problem has competing parents, so there are duplicate structures to work on. For the first problem, let's number from left to right. The parent has 10 carbons, so this is a decane. The substituents are ethyl, isopropyl, and methyl. The methyl comes last in alphabetical order, so its name becomes one word with decane. Leave a space for its number. The ethyl comes first in alphabetical priority, and the isopropyl is in the middle. Now we need to number in the other direction. From left to right, we get 4, 6, 9. In the other direction, we get 2, 5, 7. 2 beats 4 at the very first number, so 2, 5, 7 wins. 2 goes to methyl, 5 goes to isopropyl, and 7 goes to ethyl. The second example is the hardest one we'll do. There are actually 3 competing heptane parents, but we'll only look at 2. One of them is horizontal. Another one snakes through the molecule, starting from the top left. The first numbering scheme has 3 substituents, and the second has 4 substituents. More substituents wins, so the second scheme is correct. The substituents are trimethyl and propyl. Trimethyl comes first in alphabetical order because the M in trimethyl beats the P of propyl. Finally, we need to number correctly, so let's number in the opposite direction too. Numbering from left to right gives 3, 4, 5, 6. And numbering in the other direction gives 2, 3, 4, 5. 2 beats 3 at the very first number, so 2, 3, 4, 5 wins. This is 2, 3, 5 trimethyl, 4 propyl heptane. Now let's look at the IUPAC rules for cycloalkanes. First, add the prefix cyclo to the name of the corresponding alkane with the same number of carbons. This compound with 4 carbons is cyclobutane. If there are substituents, then you need to think about numbering them. If there is only one substituent, then it's assumed to be at position 1 and you don't need to number it. If there are 2 substituents, then position 1 goes to the substituent with alphabetical priority. If there are 3 or more substituents, then compare numbering schemes. The one with the lowest number at the first point of difference wins. If the ring has fewer carbons than the attached chain, it becomes the substituent. The molecule below has a C4 ring and a C5 chain. The ring is a substituent on the chain. This is 2-cyclobutyl pentane. Pause and try these sample problems. Name these molecules using the systematic IUPAC rules. The first molecule is simply ethyl cyclohexane. The ethyl is assumed to be at position 1, and there is no need to number it. The second molecule is a cyclopentane with methyl and sec-butyl substituents. Sec-butyl wins in alphabetical priority because B beats M, so it's first in the name. It's also given position 1 because it has alphabetical priority. The two schemes are 1-3 versus 1-4, and of course 1-3 wins at the second number. The last molecule is a cyclohexane with ethyl, isopropyl, and methyl substituents in alphabetical order. So this is an ethyl, isopropyl, methyl, cyclohexane. Since it has 3 substituents, we number to give them the lowest numbering scheme at the first point of difference. If we number from the top, it's 1, 2, 4. And if we number from the bottom, it's 1, 3, 4. 2 beats 3. So 1, 2, 4 wins. The methyl is at 1, ethyl is at 2, and isopropyl is at 4. You should be able to see that numbering around the left-hand side of the molecule will give you higher numbering schemes, and so we don't consider those. If you're using my book, I encourage you to do the extra test your knowledge problems for this topic so you can be sure you really understand it. All the answers are at the back. This video is closely based on my first semester organic chemistry self-help book. The book is organized into standalone topics so you can quickly teach yourself a few troublesome topics. It's also logical and organized from beginning to end, so you can easily learn the whole semester if you need to. My self-help book is particularly valuable in difficult learning situations, but you can also use it to get an edge. If you want to learn more about my books and videos, how to get the books, or my future projects, go to rescueedu.com.